Imagine standing on the surface of Venus, but instead of scorching heat and crushing pressure, you feel a gentle breeze under a sky painted with soft clouds. Is it pure science fiction, or could humanity truly transform this hellish world into a paradise within our lifetime? Welcome to Adventure into the Unknown, where we explore the world's most fascinating mysteries and untold stories. Venus is often called Earth's twin because of its similar size and mass, but that's where the similarities end. At its surface, Venus reaches over 860 degrees Fahrenheit, 460 degrees Celsius, hot enough to melt lead. The air is a toxic soup of carbon dioxide, with clouds of sulfuric acid drifting above. The atmospheric pressure is more than 90 times greater than Earth's, equivalent to being nearly a mile underwater. Yet, this hostile environment has fascinated scientists for decades. If we could somehow strip away its deadly traits, Venus could, in theory, become a second Earth, a new home for humanity. When most people think of terraforming, they imagine Mars. It's colder, but it has a more workable environment for humans. So why even consider Venus? The answer lies in gravity, size, and sunlight. Venus is almost identical in size to Earth, which means human physiology could adapt better to life there than on Mars. It also receives nearly twice the sunlight that Earth does, providing enormous potential for solar power. The 2075 date is ambitious but not impossible. Advances in nanotechnology, climate engineering, and orbital megastructures could accelerate the timeline. If humanity commits to a long-term planetary engineering project, half a century could be enough to lay the foundations of a habitable Venus. Before we can dream about lush forests and flowing rivers, we have to face the facts. Terraforming Venus is the hardest planetary engineering challenge ever conceived. Heat. Venus's thick co-atmosphere traps heat via an extreme greenhouse effect. Pressure. 90 atmospheres at the surface would crush any human and most machines instantly. Rotation. A day on Venus lasts 243 Earth days, meaning unbearably long periods of sunlight and darkness. Toxicity. Clouds of sulfuric acid rain make the atmosphere chemically dangerous. Overcoming each of these challenges requires multiple overlapping solutions, not a single magic bullet. Scientists have proposed bold and sometimes wild strategies. 1. Space sunshades. By placing giant reflective mirrors in orbit between Venus and the Sun, we could block enough sunlight to cool the planet over decades. These could be built from ultralight materials like graphene and positioned at the Venus-Sun Lagrange point for stability. 2. Atmospheric conversion. We could use advanced nanobots or genetically engineered microbes to break down CO into oxygen and solid carbon. Another option. Massive chemical plants in the atmosphere that directly capture and store carbon. 3. Floating cities as a first step. At about 50 kilometers above Venus's surface, the pressure and temperature are surprisingly Earth-like. Building aerostat habitats here could be humanity's beachhead, allowing us to live above the clouds while slowly transforming the planet below. 4. Speeding up the rotation. Though highly speculative, some have proposed redirecting asteroids to transfer momentum to Venus, gradually increasing its rotation speed and shortening its day. This would take centuries, but it could stabilize climate patterns in the long term. If you're enjoying our journey, please take a moment to like, share, and subscribe. It's free, and it helps us create more incredible adventures for you. Thank you for your support. If all the pieces fell into place, international cooperation, unlimited funding, and revolutionary breakthroughs in material science, terraforming Venus could begin in the mid-21st century and see major progress by 2075. By that time, Venus might not be fully Earth-like, but it could host vast floating cities, breathable air in some regions, and surface zones cool enough for human exploration without heavy protective gear. The first steps wouldn't be about walking barefoot on Venus's soil. They'd be about creating sustainable, permanent habitats and laying the groundwork for generations to come. Terraforming Venus isn't just a question of science and engineering. It's also a question of morality. Do we have the right to alter an entire planet for our needs? Could there be microscopic life in the atmosphere that we might destroy? Should we focus on saving Earth before transforming another world? These questions will shape the political and philosophical battles of the future as much as the technological ones. Some people believe Venus is impossible to terraform because it's too hot and too dense. While it's true that the challenges are monumental, history shows that human innovation thrives under impossible odds. Others think that it could be done in just a few decades, which is unrealistic. Even with the best technology, cooling the planet alone could take hundreds of years. The 2075 goal is less about completion and more about starting the irreversible transformation. Picture this: massive solar-powered shades glinting in space, a network of floating cities drifting above the clouds, and a sky that's slowly shifting from pale yellow to soft blue. Humans farm in aeroponic towers, children play in zero-pressure parks suspended in the Venusian atmosphere, and scientific stations on the surface begin to test crops in controlled domes. It's not Earth, but it's close enough to call it home. Venus is the ultimate test of human ambition. To transform the most hostile world in our neighborhood into a living, breathing paradise would be the crowning achievement of our species. By 2075, we may not walk freely across its surface, but we could live above it, changing it day by day, for generations yet unborn. The question isn't whether it's possible, but whether we will choose to try. What do you think? Should humanity pour its efforts into giving Venus new life? Or should we focus all our attention on protecting Earth? Share your thoughts below.